everyone, thanks for joining. So 5-6 in our book talks about applying the remainder and factor theorems. We're going to see that synthetic division that we saw before in a slightly different fashion, as well as seeing how if they tell us one of the roots or one of the factors, how we can use that to determine what our other roots or other factors are. So let's take a look at synthetic versus direct substitution. So far we've pretty much just been working with direct substitution. We did that with our calculator with the store function. So if I was going to apply this directly, I would plug in that 3 everywhere, say that x. So I would have 2 times 3 to the 4th is 81 minus 5 times 9 plus 8 times 3 minus 7. So I'd have 162 minus 45 plus 24 minus 7 and get a final answer of 134. Now, we can use synthetic substitution. That synthetic word should seem familiar. We did it with synthetic division, and in fact our process is actually going to be the same. So, we set up that elongated L, put our factor out in front. In this case they already told us it's 3. We set up our coefficients, watching out for any missing degrees. In this case, I'm missing an x to the 3rd, so I do have to put that 0 in there. Got a -5, 8, and -7. So let's see what happens. I drop down my 2. I get multiply those, and I get 6. Add them, 6, 18. Add those, and I get 13. Multiply 39. 47, 141, and lo and behold, my remainder is the same as what I got through direct substitution. The remainder in synthetic substitution, or really even synthetic division, tells us what happens when I plug in that number into my function. So, your choice, direct or synthetic. The book pretty much goes with synthetic, and I'll agree with them. It is going to be easier, particularly when you have to do it by hand, / show some work and not just do it on your calculator. So let's take a look at how we might be using this. We've already looked at the idea that if a remainder is 0, then our divisor is indeed a factor of the dividend. That original binomial, or whatever it was, went into that larger polynomial. We can use this to help us factor, I know, more complex polynomials. So they might tell you a factor, or they might tell you a 0, and from that we'll use synthetic division until what remains factors for us. So even though you might be tempted, oh, I can see, alright, I can just plug in my number with my calculator, that won't give you your polynomial that you'll then be able to factor. So let's take a look. Factor if x plus 2 is a factor. So they've already told us x plus 2 definitely goes in. If it tells us it's a factor, I should get a remainder of 0. If I don't get a remainder of 0, I need to stop, relook at my work because something's wrong. So I know that if that is my factor, my r value is -2, so that's what's going to go outside of my L. Do that check for your degrees to see if you need a 0 placeholder anywhere. I see I have a cubed, squared, x, and a constant. I'm good there. So I go with my 3, -4, -28, and -16. Drop the first term. 3, multiply, add, multiply, add, multiply, and indeed my remainder was 0. I'm good. Now remember, remainder, constant, first degree, and so on. So when I divide out x plus 2, I get 3x squared minus 10x minus 8. Now, I see that my a is not equal to 0. I am going to have to factor this. I'm going to be looking for numbers that multiply to get -24. And add to get me -10. Right away I'm thinking, how about -12, +2? So I can rewrite this. Got 3x squared minus 12x plus 2x minus 8. GCF for my first two is that 3x. So I've got an x minus 4. Take out a 2, x minus 4. So I factor to an x minus 4, 3x plus 2. Factor, if I already know that that's a factor, those are my remaining two factors. If I did indeed want all of my factors together, I could easily tack on that x plus 2 originally. Usually we just ask you, hey, find the other factors if this one's a factor. So, not a very pretty polynomial, but we are able to factor it using synthetic division. Let's take a look at one where they tell us our zeros. So if I tell you a 0 is 3 of this x cubed minus 2x squared minus 23x plus 60, what are the other zeros? So instead of just getting the factors, I am going to want to go that one step further and say what the zeros are. So let's take a look. Let's plug in that 3. Check my degrees, cubed, squared, x, constant. We are good there. Again, I know that one of the zeros is 3. Therefore, I should get a remainder of 0. If I don't get a remainder of 0, something went wrong somewhere. Maybe you forgot to add instead of subtract, but something went wrong, and do check before you go on or give up. And sure enough, I did get that 0. So, constant, linear, quadratic, and if anything, we would go forward. So I've got x squared plus x minus 20. And that's pretty nice to factor. I'm looking for two numbers that multiply to get me negative 20, add to get me 1. So I know that's going to be x plus 5, x minus 4. Since I wanted my zeros, well, 0 here would be negative 5, 0 here would be 4. And with that 0 of 3, I know that the graph of this polynomial crosses the x-axis at 3, 4, and also at negative 5. So, using these ideas, we will practice in class, and I'll see you then.